We have this function f that maps real numbers to real numbers, given by f of x equals to x squared plus ax for x smaller than 4, and f of x equals to bx plus a for x bigger or equal to 4. The question tells us that a and b are real numbers, and it's given that f is differentiable. Find a and b. The clue to solving this question is in this statement. F is differentiable. We know if a function is differentiable in a specified domain, then it means that the function is also continuous in the same domain. Since the domain of f is all real numbers, and f is differentiable, then that means f is also continuous for all real numbers. You might ask, what does continuous mean? Well, for a function to be continuous at a point, then if you take the limit of the function at that point, it should equal to the value of the function. So for example, if we have some random function g, and we know that g of 1 equals 10, well, that means if g is continuous, if we take the limit of x approaching 1 of g of x, then we know this limit should equal 10 because we said g is continuous. Now we have established all the relevant theory to solve this question. To find the values of a and b, we need to come up with two equations. We can use what we just learned about continuity to derive our first equation. So if we take the limit of x approaching 4 from the left side of f of x, and f of x is x squared plus ax for x smaller than 4, we know that this has to be equal to the limit of x approaching 4 from the positive side of bx plus a. As you can see, we consider the right and left limits separately. This is because we have a piecewise function. So simplifying the left-hand side, we get that as x approaches 4, x squared is 4 squared plus 4a. On the right-hand side, we're going to have 4 times b plus a. This is 16 plus 4a equals 4b plus a. Simplifying this, we get that 3a equals to 4b minus 16. The clue to finding the second equation is in the information that we've highlighted. Since f is differentiable, we know that if we differentiate both parts of the function f, we're going to have to get the same gradient. This means if we take the limit of x approaching 4 from the left side of the derivatives with respect to x of x squared plus ax, this should equal to the limit of x approaching 4 from the positive side or from the right side of the derivative with respect to x of bx plus a. Now, if we differentiate, we should get the limit of x approaching 4 to x plus a, and this is equal to the limit of x approaching 4 of b. So now if we solve the limit, so on the left hand side we get 2 times 4 plus a, and on the right hand side, notice that we don't have x anymore. So the limit, which is regarding to x, has no effect on b, so we just have b. And now if we simplify, we get 8 plus a equals b. Now we have our two equations, the first one right here and the second one here. Now you're free to choose the method you want to use to solve these two equations. You can use simultaneous equations, or you could just substitute the value 8 plus b for b in the first equation and then find a, which is what I'm going to do now. So if we go down a bit, so we know that b equals to 8 plus a. So if we substitute it into the first equation we get 3a equals to 4 times, and b is 8 plus a, so 8 plus a minus 16. So we have 3a is equal to 32 plus 4a minus 16. Now to simplify this, we just take the 4a to the other side. So 3a minus 4a, we get a, negative a, sorry. And 32 minus 16 is just 16. So we have that a is minus 16. Now we know the value of a. We can substitute back into the second equation we got to get the value of b. So we know 8 minus 16 equals b. So this is minus 8 equals b. And now we're done since we found the values of a and b. The important takeaway from this video is the relationship between continuity and differentiability. So if they give you that the function is differentiable, then that means the function is also continuous. Note that the opposite does not apply. So a function could be continuous, but it's not differentiable. An example of this case would be, for example, y equals to the absolute value of x. If we draw the graph, we will get something like this. As you can see, this function is continuous. However, at x equals 0, so here, exactly at x equals 0, we don't have a gradient. We can't differentiate this function at x equals 0. So therefore, continuity doesn't mean it's differentiable. Therefore, if a function is continuous, that does not imply it's also differentiable. However, if it's differentiable, that does imply that it's continuous.